Hey, what up, buddy? How's it going, man? Found you in the daytime, huh? Hanging out the sun for just a bit here. Figured I'd jump on and do a little bit of solar live. If I can get everything popped out, be able to read it better. There we go. One more. How's your day? Ah, dude, that's good, man. Hey, Ron, what's up, buddy? Himanshu, what's up? How's it going? I didn't mean to actually throw both the lives on the vertical and the horizontal, but vertical and horizontal it is, I guess, today. I'm doing good, Thomas. How you doing, bud? My chat is not even popping up in the stream like it normally does. It's kind of wild. Glad you're not sick anymore, though. Always good to hear. All right, move it up here. I'm doing good, man. Yeah, I'm doing great. I'm doing great. Hanging out with the sun. If we can move it over the telescope. This is the 8SE right now. Currently using the 8SE telescope. It's kind of cool. You get to see how many sunspots we have on the sun currently. Pretty wild. Plus, you can see a little bit of a dust spot there too. We pulled over a little bit more. And up in our view a little better. Sunspots is cooler regions on the sun. When we talk about the sun itself, they're areas where the magnetic field, they intertangle, and then the plasma just can't reach the surface of the sun. So they're cooler regions. When I say cooler regions, about 7,000 degrees Fahrenheit compared to the surface, which is about 10,000 degrees. Quite a bit difference in the temperature for sure. Really cool view of the sun. All right, where's my other key? Oh, it's right here. There we go. Oh yeah, dude, sun's pretty cool. You can see solar flares. Not with this setup. Gonna have calcium K in the like type filters to get solar flares. Color regions. No, still yeah, only Chuck Norris can hang out with the sunspots, of course. Let me pull it back over a little better. I'm not using the main setup that I normally use at night. This is the 8SE on the 8SE mount with the wedge on it. This is the sun. We're looking at the sun right now. Take astronomy class for an elective. Oh, dude, I'm so excited. Man, that's awesome, brother. That's super awesome, dude. That is really awesome. Super excited for you. Super excited for you. All right, let's see here. Robert, I appreciate that, brother. Thanks, man. I got two different YouTube streams going. I didn't mean to. I have both the vertical and the horizontal going. I only meant to actually kick on the vertical, but I guess now I gotta pay attention to two streams while doing the sun. Looks like an egg. It's pretty cool, ain't it? The sun is really, really gorgeous. It's actually white light. When we talk about the sun, it's actually white light, but we see it more yellow here on Earth because of our blue atmosphere. Hydrogen and helium in the sun's surface. Mostly hydrogen. When we look at the sun, we look at mostly hydrogen. There's still some helium, obviously, and this is what's being fused at the core of the sun. And then eventually we'll get heavier elements up to the point about iron. Iron gets a little too heavy, and then we'll lose the balance between gravity and its atmospheric pressure, and it'll go poof. It'll blow out the atmosphere, which would be called a nova. It don't have enough mass to go supernova, so it'll just go nova. We'll have behind us, we'll have right behind us, it'll be what's called a planetary nova. This is day image. Yep, this is looking at the sun right now. It is currently 12:09 p.m. here in Kansas City. This is the sun. Looking at the sun. If I move the telescope just a bit more here. There we go. Yo, what's up, Safe? How you doing? Not so many black sunspots right now. I mean, on the surface, I can see. If we zoomed in, we'll see a lot smaller ones. Let me look up what the actual count is currently. By the way, you can go to Space Weather Live, which is also a good application to install, and it'll give you some of that information. I'll tell you right now. Sunspots 137, so it is down 12 sunspots from yesterday. Down 12. Why it's orange? Since sun is white, so it's white light. It's orange because of the filters that we tend to use. It makes it more common to what we see when we look in the sky. So they put like an orange tint or hue. So the other thing is, obviously, we're using a camera, so I can actually change the color balance. So we can actually make it nearly about any color. If I were to white balance it, then this is basically what we see here. But I think a lot of people understand the sun to kind of appear more orange to them. That's kind of what we're so expected to see. So sometimes running it like this is a little bit easier to understand what we're seeing. Yeah, this is a white light filter. Currently using a white light filter. It's a good thing, right? Some spots. I mean, yeah, like if you like looking at the sun's activity, we're still in maximum solar maximum, so it's still really cool if you're really interested. And this gives a really good time to actually understand our sun and understand the energy from the sun. Have you heard of the three eye, not 3-1 atlas, but 3-eye atlas? Yeah, absolutely. Why are sunspots? Why are they consistent? They're really not, man. They come and go. They can last hours, days, and even up to weeks. I think some of the longer ones are a couple months, but they're not consistent at all. Kind of just stare at the sun. If you get like a white light filter or a really good pair of welder binoculars or welder helmet, you can get solar binoculars even, or even a white light filter for your telescope and be able to check out the sun. Just make sure you're safe. Obviously, don't just look at the sun. This is looking through an 8-inch telescope right now with a white light filter on it. So we get to see basically the surface of the sun where the sunspots are. Dan, I would probably say, man, make sure you get solar binoculars or just don't touch glass at all. There are solar binoculars you can get. Hey, Karen, what's up? Grasp the cause of the sunspots. So the sunspots, what happens is, yeah, dude, it ain't something to kid about because there can be people that actually go for it. It's just weird, man. So sunspots we see because the North Pole and the South Pole of the sun, they swap. And as that occurs, the magnetic field, they'll intertangle with each other, causing these kind of voids where the plasma can't come to the surface of the sun. And that's what we're seeing here. It's a much cooler region, so with the white light filter, they appear darker. They're still really hot, though, 7,000 degrees Fahrenheit. Right now, I'm looking at the sun, currently hanging out the sun. Telescope for viewing the sun. This is the 8SE with a white light filter on it. Make sure I got the rest stuff here. What's the maximum cost? What's the minimum cost of a telescope? Yeah, dude, yeah. Look for somewhere like that range of 100, 300. It's a good beginner. That's not the only president who does hydrogen also. Hydrogen is the most common thing that we see with the sun. Hydrogen is actually the most common element in the universe itself. This is the sun. Yep. Just one filter, just a white light filter on the front. It's not always a precedent for solar flares, but solar flares are most common to see around the sunspots. But rarely, we do have occasions where a solar flare will occur and not actually there at the sunspot. But usually, yeah, you see the solar flares in the Penumbra area of the sunspots, which is that kind of like a little darker grayish area. They're still really hot in that region. It's where a lot of your energy actually occurs, the friction, and that's when we see the solar flares come from it. Hey, what's up, Dom? How's it going, man? What's your declination and right ascension? Depends. I mean, we're looking at the sun. I'll have to look at the actual declination and right ascension for the sun right now. Let's see if I can grab it out of CTPWI. So we are looking. They'll give it to me right away. Declination is 2154.5, and RA is going to be 1219.36 for the sun. Get my chat back up again. I'm doing good, man. I'm doing really good. Enjoying the weekend. How are you guys? You guys having a lot of fun with the weekend? Having a good weekend so far? Watching from Australia, dude. No way. Welcome in. It's getting pretty late over there, right? And you guys are coming up on, you're in spring now. Very nice. The original one, yep. When the next solar flares, nah, dude, there's been a lot of solar flares recently, though. But no one can predict when the next solar flares are going to occur. Nothing too bad's happened. That's good, man. That's really good. 3:15 a.m. Wow. Was it perfect circular? It's gravity. Gravity's going to pull it in. That's how it works. There's a lot of like filaments when we talk about the sun itself. There's filaments that you see on the sun. There's prominences that we see on the sun. But with this filter, we don't see those, though. If I can pull it over a little better for us. Which way do we need to go? Top. Okay. Just asked, didn't think your answers. Oh, man, you're good, man. Absolutely. Let me pull it over here a little bit more. There we go. Large blackish patch in the lower right part of it. In your view, that's going to be dust. That's dust being picked up by the camera. It happens too. It's daytime where I'm at. It is 12:16 p.m. here in Kansas City. 12:16 p.m. Hey, what's up, Astra? How's it going, buddy? How's your day? Yeah, just a little bit of dust. It's not shining as bright as it usual. And sarcastic. I mean, with the wildlife filter, obviously it helps, but like, oh, nice. Yeah, I'm in Kansas City. I'm over in Kansas City area. So we pulled over a little better here. I don't have the so I'm not using the common mount that we use at night, like when we're doing the planets. This mount I just kind of tossed out there. Yeah, Red Kingdom, right? This mount I just got. Oh, you're in Leesville. Okay, I got you. But basically, I threw this mount out into the observatory, rolled off the roof just a bit, just enough for this telescope to be able to look out and not have any issues with everything blocking us, per se. Video de tomar un video. Yo no. Cuando November, 2 más meses, y vámonos a mi telescopio por Tracy. Can we pull it over a little better? So yeah, you can see I'm having to mess with the mount every now and then, send different signals to move the telescope just a bit, because obviously our tracking sucks right now. What's your thoughts on 3i? It's going to be an interstellar comet, most likely. It's done release a absolutely massive coronal mass ejection directly at Comet 3i, completely vaporizing the tail. Yeah, separation of tails are pretty wild. When you get into like solar maximum, it gets really, really wild of separation of tails. It's really, really wild. I wish this telescope, I need to, so it's a mount that I'm not used to. So as you can tell, like I'm hitting the wrong buttons here and there. Was like cigar shape not broken down. Like most things like that come interstellar, it's hard to study them, right? We got a lot of really odd shaped even asteroids here, and even comets here in our solar system. Take Phobos, for example, a moon near Mars, which is really funny looking. It looks like a potato. It's just kind of common for scenarios like that to occur. It's just how they start to build up. They connect with another object during the early formation, and so on. Yep, the sun is white. It is white light. Our sun is white light. It peaks high on the green spectrum, though. So we actually talk about the higher spectrum of the sun itself is on a greenish color, a greenish tint, even though it is a yellow dwarf star. Crab Nebula, supernova, yeah, absolutely. Pull it just a bit down a little bit here. There we go. It's not the yellow light. It's the blue. It's the blue light bouncing off all the elements in our atmosphere and leaves behind red and green. Leaves behind the red and green. So when you get that higher spectrum of green and then the more calm red, you just get this yellow hue. Gives a video of Marches and 3i Atlas. That isn't misleading, real. Honestly, I can't see 3i right now. 3i is going to be a lot easier to study. So there's all the equipment basically on Mars are going to be looking at 3i right now and trying to figure out kind of what's going on there. And then eventually it's going to go through its closest approach to the sun that's going to come out. So somewhere around October 30th, October 31st into the beginning of November, we'll get to study it a lot more, right? It's a lot easier to study as it's on its way outwards than it is when it comes inwards, because it's so fast, it's so darn fast, and it's hard to see when it's coming up towards the sun. But as it's leaving the sun, it gets a lot easier to actually watch and try to study. The truth is, like, we won't have all the data until sometime next year in the first place to even make a solid confirmation of what's going on there. So like the videos coming out right now should just basically be, it's an interstellar object, and we're still researching what's going on. What does it look like spray paint? It's a white light filter. I'm using a white light filter on the telescope. Anybody saying that 3i is an alien is clearly just getting you to click a video. It's just all about you clicking a video, making them money. That's all it is. There's nothing that represents anything there that would be of concern of that scenario. Yo, Green's from the West Coast, right? Composed rap and R&B music. That's awesome, man. Welcome in, by the way. Glad to have you here. We can pull it over a little bit better. 3i, most likely going to be a comet. It's most likely going to be a comet. The honest truth is, if we don't have that answer yet, but it's most likely a comet. We'll know for sure, though. There'll be better understandings of it by probably about in the middle of next year or so. Nah, there's nothing to do with intelligent guiding. What's really wild about it is how how it came through, and it's pretty much on the same plane as the rest of our planet. So that's a pretty rare instance to occur. But obviously, and again, the one thing you got to remember, it's not a green star. It is a white light star. It's a dwarf yellow star, but it peaks in the green spectrum, though. But anyways, the thing about it is the third interstellar object that we've actually seen. So it's kind of hard to really understand those aspects of how do interstellar objects actually interact as they come into our solar system, how they interact with the sun being in solar maximum. There's a lot of different things going on there. Absolutely, Robert. Yeah, absolutely. Right now we're doing this as a hobby for sure. We live stream this as a hobby. We can pull it over a bit. Oh, going the wrong way. Looking for solar flares. You won't see solar flares with this, or even the with the white light filter. You won't see solar flares, and we won't see prominences, and we won't see filaments. You got to have hydrogen alpha to get more of the prominent side, and then you got to have calcium K to be able to do stuff. You can get different types of calcium filters, but to get the solar flares. This is one of my telescopes. Yep. Dom, appreciate it, man. I appreciate that. Someone who's watching the sky, you'd be more aware. On what? What are you talking about, dude? Thank you, Helena. Thank you. It's not going to be that telescope. I'm using the C8 right now, or the 8SC. Anything burn in the sun and hit the sun? Have you seen anything? No, I haven't. That takes a lot of difference when it comes to observing that kind of stuff. Has something to do with that? No, it wouldn't have any kind of influence to an earthquake here on Earth. Even the moon, we don't even see anything from the moon that causes an earthquake here, even in our planet. That would take something pretty well. McCann, thank you so much, man. Appreciate it, buddy. I appreciate that. This is Kansas City. I'm located in Kansas City. Oh, I see that dude said, good luck when you get here. Oh, he's one of those cult members. I get it now. I get it now. Yo, Kathleen, thank you so much. Hopefully tonight we're going to be on with Saturn. Should be on with Saturn tonight. It'll be a lot of fun. If we move the telescope just a bit more here. Gotta get so used to running this control because it's not the normal mount that we use when we go live at night. This is the 8SE on a wedge. It just kind of acts a little different for me. Logan, thank you so much, buddy. Sun gazing during a coronal mass ejection. I mean, it happens a lot, right? CMEs occur quite frequently, but I don't have the right setup to see it, though. You need at least hydrogen alpha to do that. Binoculars made for watching solar cuts. Oh, dude, yeah. I get a weird look from people when they start seeing me with the sun and binoculars. Dude, I love that, Gary. Yeah, absolutely. Solar binoculars are a lot of fun. They're really cool to have. Make sure I keep up. The sun is technically green star. It is. And that's the bad thing about astronomy, right? Like, we looked at the sun before we actually understood how the spectrums worked and considered a yellow dwarf star. Even though it does peak in the green spectrum, it still looks like white light, though. It still looks like white light, but you can see in the spectrum that the green peaks. Yeah, those aren't supernovas. Those are just novas of a star, and it's not rare. Recurring novas occur frequently. Even star novas occur pretty frequently. Those are novas, not supernovas. Personality, it would be, absolutely. Absolutely. There's 4 giant sunspots. There's a lot of little ones on here, too. I can see quite a bit of little sunspots. It is white light. When we talk about the sun, it's white light, but it peaks in the green. Guys, what's up, Gobbler? How you doing, buddy? Telescope, can you see people walking on the moon? Nah, man. Nah, it'd be something really small. Just consider the things I can see on the moon would have to be somewhere like on a really, really good night, even using the 11-inch telescope. You're probably going to see stuff in the range of 5 to 10 miles minimum, very minimum. You wouldn't see like a person on the moon itself. Wrong way. Go the right way, son. Keep hitting the wrong buttons. You guys all excited to be coming into October? Anybody ready for spooky season? Anybody getting excited for spooky season? Get this pulled up here. My chat just quit updating for some reason. Why is my chat's not working? Sorry, guys. My chat just completely stopped working on my side. I don't know why. Pop out. If I can get it to come back up. Oh, there we go. See if this helps any. Oh, man, you guys said a lot that I missed there. Holy moly. You don't believe the moon's real? Okay, cool story. This is the 8SE right now. This one's about 1600. The 8SE is roughly about 1600. Is this the moon? No, it's the sun. Keep coming through. Wow, I missed a lot of chat. Holy moly. I'm sorry, y'all. I'm so sorry about that. Aaron says, so the waves that we're seeing are those currents radiating from the core. The waves that you're seeing is going to be our atmosphere. There's different things in our atmosphere. Our dark spots, those are sunspots. Those will be beautiful sunspots on the sun. We pulled over a little more. Hey, Snow, what's up, buddy? Yeah, this is a filter here. This is a white light filter on the telescope. Sunspots are cooler regions that we see on the sun. It's because of the magnetic fields intertangling with each other and cause it where the plasma just can't reach the surface of the sun, the surface that we're viewing here, obviously. So it appears a little darker for us because obviously the hotter regions, they show up brighter than the cooler regions. So if you can notice that, like, we don't see anything else but the hotter region right now. So we're looking roughly in the areas of about the darker regions are roughly about 7,000 degrees. The surface of the sun is about 10,000 degrees. So Vocal, it's almost like they have nothing. Yeah, I don't know, man. Honestly, I have no answer to it. How do you not get glare? This is a white light filter. You got to pull back a lot of brightness to get where the glare doesn't occur, of course. Yo, what's up, Devin? Not solar flares with this setup. Solar flares, you need like a calcium K, for example. Get into the calcium area. Hey, you're welcome, dude. Absolutely. The hydrogen rain on the sun. So I do not. I don't have a hydrogen alpha telescope. Just white light. Most of my stuff that I do is obviously at night with planetary, and so hardly ever do I actually look at our sun. But today we are. Today we hanging out with the sun. Sun is a gas, not a liquid, not a solid, but it's a gas. And not burning, it's fusion. You're welcome, Logan. So the sun is, what it's doing is it's mostly hydrogen. Near its core, it's fusing hydrogen into helium, and eventually it'll continue to do that until it starts to fuse other heavier elements up to the point about iron. At that point, it's just going to be too heavy of elements to be able to maintain the balance between gravity and atmospheric pressure. No, the sun itself is gas. What occurs in the core because of pressure would be from what we call plasma. Plasma is when the elements fuse together. We are hanging out the sun. Nice. I love it. Let's see if I can pull it over. Again, I'm using a completely different mount than I normally use at night, so this thing can be kind of like a little bit confusing. Fusion, not fission, but fusion. Get a plasma laser at work? Ah, no way, Logan. That'd be a lot of fun, man. Always want to try one. Do a little bit of plasma cutting on metal. I'm sure that's a lot of fun. Go stream later tonight? I believe so, man. Should be good for tonight for sure. Should be good to go tonight. Probably get closer to iron before it gets there. It's going to go really fast at those points, so gravity's going to get so intense that it's going to be able to fuse much quicker. But eventually it's going to get that heavier element. It's probably somewhere around iron before it goes. That's a good question. Is it going to be big enough to get the iron? It's going to be a hard question. The thinking is it's going to fuse really fast. Once you get to a certain point, fusion occurs much quicker. So will it hit iron? That's a good question. No one really knows. It's a good estimate though. But somewhere around iron, it could be before iron, could be right past iron. A lot of stars tend to go. There's a lot of energy. When we talk about the sun, yeah, the energy occurs from its core, though, where it's fusing. Waiting for Jupiter, woke up at 7 a.m. Oh, no way, man. I didn't even get to Jupiter this morning. I ended up feeling sick last night and jumped off. I still don't even feel good right now. What time tonight? Probably going to be around 10 p.m. Central Time. It's a beauty, for sure. Very beautiful star. We have a beautiful star. Do you ever look at Jupiter? We do. 2 nights ago was the last time we looked at Jupiter. We're still not really in Jupiter season. It does come up around 1 o'clock in the morning right now. but we're probably about a month out from really getting the best views of Jupiter, up to end of January, which it'll be in opposition, and we'll see it again January, February, into March from the observatory here. You're welcome. What's the sun's rotation compared to Earth? Different, because it is a gas. It's not a solid like us. So it's a little different rotation. Depends on where you're looking at. So if you're looking like towards like the average, then you're gonna be like 27 days roughly. So it takes about 27 days on average, but the equator is much slower than what it is at the pole. It rotates at a differential rotation because of it being a gas. No, it don't produce more gas. It can collect other elements like when stuff gets near us, but it pretty much has the energy that it's going to have. Hi Ali, how's it going? Welcome in. Kansas City. I'm over by Kansas City, USA. Just recently found out that they're barreling through our galaxy speeds that human brain can comprehend. Yeah, things are really on the move. Like when you talk about the universe in scale, it's crazy, crazy, crazy. Ever see a solar flare? Not with the setup. We don't see solar flares this setup. I've seen solar flares, but not with the setup we're looking through. We move it over a bit. Oh, it's rotating so fast though, because if you compare the size of the sun, and its rotation is insane. The sun, you can put about 1.3 million of our planets in it. It's insane. This is the sun, hanging out the sun right now. Saw aurora here in Alabama a couple years ago. Yeah, absolutely. The auroras last year were insane. They were amazing, absolutely amazing. Back here again, a great sleep. What's up, Caesar? How you doing, brother? How with a this is a telescope and a white light filter. How's it that big? Oh, it's just that big. A lot of things are big. This is actually still a relatively small star. Our sun is a relatively small star. There are much larger stars out there. It's an average star, but it's small compared to the other stars that are massive. It's a relatively small star. Hold over a bit more. Up a little bit as well. There we go. His day there. How you frame the surrounding area of the sun? So there's a couple things you can do. One, you can use the shadow from your telescope. Two, if you use a piece of paper and put it behind your optics, and you can see the light coming through, and then you know that you're framed up. Hi Lewis, how you doing, man? Welcome in. James was changing our understanding of the universe. Yeah, absolutely. So the asteroid belt separates gas and solid planets. That is where the separation is, but the asteroid belt's mostly there because of Jupiter itself. It's not that it's what separates the gas and terrestrial planets. It's just it was there because of Jupiter, and Jupiter is just crazy. Yeah, it is the currently 12:37 p.m. for us. I'm in Kansas City area. Hey Stridon, how you doing? Fighting about everything. I agree, man. Yeah, absolutely. We can be looking up instead of looking down for sure. No problem. How you doing, man? How's your weekend? Where? Me? I'm in Kansas City, Missouri. Telescope a bit more. Oh, Anders, thank you so much, man. Appreciate it. A calm experience like this is sometimes great for us. Good for the soul for sure. Oh, the sun set for you 30 minutes ago. Wow. You're ready to go out and check out Saturn then. This ain't a planet. This is the sun. This is our star, the soul. Our soul. Gorgeous, huh? Yeah, those sunspots are massive. They're massive. It is. I think so too. Right now I'm using the SV405cc from SV Bunny. It's definitely good for the soul. Looking up is always a good thing compared to looking down. Can we pull it over a little bit? A little more. Yeah, that's the sun right now. That's a live view of the sun. This is a sun through an 8-inch Schmidt Cassegrain telescope with a white light filter on it. Overcast in California. We call that smog. I know you guys call that something else, but we just call it smog. I'm joking with you though. Oh man. Oh, thanks, Maria. I appreciate that. Ah, thank you, Emily. Honestly, thank you. You know, I'm glad that you're enjoying it. Honestly, I'm glad you're enjoying it. I happen to know what the rate of the sun expands. Like, would it be 500 years to start feeling difference? When we talk about our planets, roughly, our planet has about 1 billion years left, to the point that we're going to get to a horrible scenario with the sun itself. We're probably about 4 billion years, and then from that point outwards, it'll probably somewhere around 5 to 6 billion years, and then we'll go nova. Nighttime there in Europe. Oh, okay, I got you. I got you. Are they sunspots? They are. Yep, we can see sunspots with, through this filter. ADHD in my brain goes 1,000 miles an hour. Dude, I hear you. I definitely hear you. I get it. Let me pull it over a little better. There we go. Hey, what's up, Chili? How you doing, man? Welcome back, bud. Didn't expect it, yeah. It's not perfectly spherical per se, but I mean, obviously at this distance and this size, it's going to be really close to it. I'm using a tracker, but I don't have it all set up properly. I'm doing good, man. I'm doing really good. Oh, thanks, Dano. And again, tonight we'll be live streaming Saturn. Saturn will be the target somewhere around 10:30 Central Time tonight. We'll be starting with Saturn tonight. For all the solar flares I hear about, we can't see solar flares with this. You need like calcium K. We're looking at the sun, our sun. Pinhole, oh yeah, pinhole reflectors. Any watching clip, that's really cool. Pinhole reflectors, like the box pinhole reflectors, are really fun. So we can pull it up a little bit. Move over. Oh, there went something through. Do you guys see that? Looked like a bird or something. I could barely see it. Some of the frames, you could actually see some of the movement there. Do you guys see it? Just mind blowing, yeah, it really is. It really so wild. Looks so sick, yeah. Solar flares are really fun. So mind blowing, that's awesome. This is the sun, yep. Looking at the sun right now. Some of those color filters cost more than my scope. They get expensive. Hydrogen alpha, like, is, if you really want to get into hydrogen alpha, it's about $1,000. It's much cheaper than most of my other equipment. It's just one of those things that I don't enjoy setting in the sun, so I tend not to. That's why you don't see me streaming the sun a lot. That's why I don't have hydrogen alpha telescopes or calcium filters. It's because I burn, and I just dislike the sun so much. No, it's daytime for me. It's daytime. It's 12:43 p.m. for me. Subscribe to your channel. I'll be looking forward to seeing Saturn tonight for this year. Dude, that's awesome, Tom. Be glad to have you in, man. I'll remember you too. Absolutely. Hi, Nicole. Thank you so much, Nicole. I appreciate it. Can't wait to see his live stream tonight. It's a lot of fun. I appreciate it, Emily. We'll be on here. Last night I got kind of sick, so we were going to end up like Jupiter and looking at a comet last night. That was a game plan. But somewhere around like 2:30 this morning, I just didn't feel good. So I ended up calling it. And since I went to bed a little earlier, I figured I'd wake up today around 8 o'clock and done a few things, got a few things done, hung out with my son for a little bit, and then figured I'd come out here and do this. Definitely see you tonight. That's awesome, man. Nah, thanks, Nicole. Appreciate it. Expanding outwards from the sun. Very dynamic. It is. The sun is very dynamic. It's truly a dynamic sun. Let's see if I can do a little bit of focus. Do you guys want to check out some of the sunspots or no? We can do some zooming in and check out sunspots if you guys want. I gotta find the, where's the focuser? Oh, right here. I found the focuser. We should stay in a position. I can find it easier. There we go, though. That should work. We can zoom in if you guys want to see some of the sunspots and the number around them. Do some zooming. Let me get my chat back up too. Can't see my chats. Check out some of the sunspots. We can do it. Let's see if I can change the capture area on the camera. Let's go to about like a quarter of the view, maybe, just to see what it looks like here. Zoom in quite a bit, see some of the stuff. Let me get rid of our black box down here. So annoying. That's where my camera usually sets, the outside camera. But if I turn on the outside camera, it blows out because the exposure on it's so high. There we go. Now we can see a little bit more. See a little bit more of what we're seeing here, and then we'll try to pull in some of these sunspots. Try to focus in as well. All right, let's see if we can focus. Which way we need to go here on the focuser? Go a little more. Looks like we need to go the other way, huh? Get it focused in as good as I can here. Yeah, there we go. That's not too bad. It's not perfectly focused, but you can kind of see how like dynamic the actual sun is when it comes to sunspots. There's some really small sunspot regions here that we typically don't see very often when we're completely zoomed out. Whoa, I went too fast. Went way too fast on it. There we go. Yeah, you can see some really cool, beautiful sunspots there. Bring the other ones back in. Yeah, really beautiful though. How long they usually last? It can be anywhere from minutes to hours, obviously. The longer ones are roughly about a month to 2 months, but normally about days. Days are the typical period that we see with them. All right, let's zoom back out real quick. It is so zoomed in that it kind of makes me nauseous watching. I ain't gonna lie. It was way too crazily zoomed in. There you guys go. Make it easier to see it anyways. Otherwise, I would turn on the, if you guys wanted to see the telescope itself, I would try turning on the camera, but it is blown out because of how bright it is, obviously. All right, let's see if I can get everything pop back up here again. Gotta get all the chat to pop up. Where is that? Right there. No, it's not an iPhone, it's a telescope. Ah, thanks, Diane. I appreciate that. I appreciate it. Beautiful sun today, though. See if I can move it over a little better here. Move a little faster. I'm trying to get the rate to where it's a little bit more responsive, like when I hit it, but like that was way too responsive. I gotta bring it back into view. Now I'm way past again. Oh my goodness. Come back, son. Try and go slow here. There we go. There's the sun. Let's see. Slow it down when I go this way. We'll let it kind of come through our view here. There we go. My goodness. Wow. It is alive. Our sun is very dynamic. There's a lot going on with it. Right now we're looking at the sun. Hanging out the sun. Make sure I got that, both chats here. How long do you usually last? Or, oh, okay, I got that one already. Nearcams are doing more, except they are. I had an iPhone 11 that was able to see sunspots. Like when you put like a solar filter in front of it. I've never had my iPhone ever have sunspots. Without a solar filter, of course. Leah from Colorado. Glad to have you. I'm over by Kansas City. We're over by Kansas City. The air conditioner here in the observatory is running hot right now. It's probably because it's at 79 degrees. I don't know. No, not Mara. Not Mars. It's the sun. Hanging out with the sun currently. Oh, thanks, Emily. It's an egg yolk? Okay. Cool story. Cool story, bro. Oh, there's my alarm, y'all. Let's see. I gotta actually go run an errand here really quick. So we'll probably be disconnecting here shortly, but give it a few more seconds here. Hang out that beautiful sun. Sunspots are not what we're talking about here. That's funny. Hi, Thorsten. How's it going? Again, tonight we'll be on with Saturn. Saturn will be the target that we go for tonight, probably around 10 to 10:30 Central Time. It'll be a lot of fun. Yeah, Streamlabs being a moderator is super awesome. It grabs some crazy stuff for sure. Where are them aliens? I don't know, man. I'm not sure. I'm not sure. Can't tell you. They're here in the chat. Some of the people in the chat are the aliens. That's funny. That sounds good. Yeah, absolutely. It's a lot of fun. Yeah, absolutely. It's really fun. Alien feels like the Earth's flat. Poor alien. Imagine joining a cult thinking something like that. That'd be crazy. It's true. I'm an alien, said Derek. Yeah. They live inside the sun. Nah, man. Chuck North's the only one who can get to the sun. Chuck North's the only one who can get to the sun. Yo. Y'all enjoying the weekend so far? Everybody having a good weekend? This is the sun. We're looking at the sun right now. Looking like a fireball. It's not a fireball. The sun is not a fireball. So right now we're looking at the through a white light filter. So what we see is this, basically the surface of the sun with some sunspots. Is it true, sun? Is it true that the sun is white color? It does. It is white color. We see kind of yellowish, orangish, reddish here on Earth because of the red light, and the green, obviously. But the blue light's actually very energetic, so it makes our skies blue during the day as it hits all those weird elements in our atmosphere, obviously. But it's white light. It peaks highest in the green spectrum, but it is white light. Got the window of here. That plane, tell me. Ah, man. Our hair changes the size of the tail, and so two types of consciousness. They're in lack of control, self-control. Yeah. Okay. Cool. So we pull it over a little more. Come here, son. Few more minutes and I'm going to wrap it up until tonight. And again, tonight we'll start out with the beautiful planet Saturn. That is going to be the game plan. And it's going to be about 10:30 p.m. tonight, Central Time. Oh, thanks, Emily. Honestly, thank you. Would drive everyone mad. It'd be very noisy if it came through here. Yeah, absolutely. Be super noisy. A lot going on. A lot of energy. The sun has a lot of energy. The Sun Orbiter. Oh, a Parker space probe. We see Pluto. Is it too far? So we can see Pluto. Some of my telescopes do pick up Pluto. Right now we're looking at the sun. Right now we're currently looking at the sun, not a planet, but our star, our sun, Sol. What's up, Grayson? How's it going? Will the sun eventually burn out? It don't burn. Eventually it will go nova, though. Eventually it'll go nova. All right, Dom. See you tonight, man. See you tonight, buddy. Thanks, Gobbler. Appreciate you, bud. Ah, Joe Dirt in the house. What's up, man? How's it going? We can see Pluto with this telescope. This one can pick up Pluto. It's an 8SE. This is the sun, not Mars. Oh, Earth will be cooked before nova. Dude, Jupiter I can't capture until about 5:30 a.m. before it gets high enough for us to be able to see it from the observatory here. What is this? The sun. This is our beautiful sun. All right, y'all. I'm gonna call it. Until tonight. I'll see y'all tonight at about 10:30 p.m. Yeah, that's our sun right here in white light filter. I'll see you guys about 10:30 p.m. Central Time with Saturn. You guys have an amazing Saturday. Unless you're on the other side of the planet, you're getting ready to come on Sunday. Have an amazing night for sure. And we'll see you guys tonight. Clear skies, y'all.